Prince George's County Public Schools presents HSA Prep for Algebra and Data Analysis. All problems will come from the public release problem sets, which are accessible to students through the Maryland State website at www.mdk12.org. Once again, that's www.mdk12.org. HSA Prep, because now it counts.
Hey everybody, this is Mr. Owens here with your HSA prep session for today. Remember, we're preparing you all for that Algebra Data Analysis High School Assessment. So in this session, we're going to focus on Goal 3. So let's take a look at Goal 3. Goal 3 deals with data analysis and probability. It says the student will demonstrate the ability to apply probability and statistical methods for representing and interpreting data and communicating results using technology when needed. So primarily in this section, we're going to focus on our Goal 3 standards and our Goal 3 indicators, okay, and expectations. So let's take a look at our first problem for today. Our first problem involves our friend Jeremy. Jeremy plays soccer. He scores a goal in 40% of his games. Jeremy wants to design a simulation using a spinner to predict the probability that he will score a goal in 8 out of 10 games. Which simulation design has an appropriate device and a correct trial? So in this case, we have to take a look at a couple things in our problem. The first thing we want to look at is what was the probability of Jeremy scoring a goal. It said the probability of Jeremy scoring a goal is 40%. So let's take a look at that in our problem. It says he scores a goal in 40% of his games. That's important. And it says he wants to design a simulation using a spinner to predict the probability that he will score a goal in 8 out of 10 games. Now that 8 out of 10 is very important because that's telling us the number of games that we're looking at seeing whether Jeremy scores a goal in. So we're looking for 8 out of 10. So the question is, are we looking at his goals in 8 games or 10 games? So based on what we have in the problem, it says 8 out of 10. So out of 10 games, we want to see if he was able to score a goal in 8 of those. So out of the 10. So we're looking for 10 games total. So now based on that information, because that's very important and that can help us eliminate one of our answer choices. So let's take a look. So remember we said we want to find the probability that he will score a goal in 8 out of 10 games. So it's out of 10. So that means if we're going to perform our simulation, that means we have to perform it at least 10 times because it says 8 out of 10. So if we look at some of our answer choices, first answer choice A says divide the spinner into 5 equal sections, labeled 1, 2, 3, 4, and 5. Spin the spinner 8 times. Now is that going to work? No, it's not going to work, right? Because we said he's trying to do 8 out of 10 games, right? 10 games. So we're going to eliminate answer choice A because it tells us to spin the spinner only 8 times. So that would only give us his probability for 8 games. Now let's look and see if we find another one that says spin the spinner 8 times. Oh, I see another one. I see C. C also says that. Spin the spinner 8 times. So if you only spin the spinner 8 times, you don't get 10 games because remember, each spin of the spinner counts as a game that Jeremy played. Now let's take a look at our 2 answer choices that are still available. So we have B and D. So B says divide a spinner into 5 equal sections, labeled 1, 2, 3, 4, and 5. Spin the spinner 10 times. So let's take a look at a spinner that's actually divided into 5 equal sections. So here we have our spinner. And this spinner is divided into 5 equal sections, labeled 1, 2, 3, 4, and 5. Now the question is, does this spinner represent the probability that Jeremy will score a goal? Remember, the probability that Jeremy will score a goal is 40%. Now, if we wanted to write 40% as a decimal, we could take our decimal point and move it. We have 40%. Take our decimal and move it 1, 2 places. So 40% as a decimal would be 40 hundredths. And if we want to change that into a fraction, that would be 40 over 100. Now, if we simplify 40 over 100 by dividing our numerator and denominator by 20, we'll see that we come up with 2/5. So in order for us to be able to get a probability of 2/5 or 40%, our spinner has to be divided into fifths, because 40% is 2/5 as a fraction. Okay, so now, is our spinner divided into fifths? Yes, it is, because we have sections 1, 2, 3, 4, and 5. So B sounds pretty good so far, because it tells us to divide the spinner into 5 equal sections. It says divide the spinner into 5 equal sections, labeled 1, 2, 3, 4, and 5, spin the spinner 10 times. That sounds pretty good. But let's take a look at D just to see if maybe there's a chance that D may be correct as well. So let's take a look at D. Now D says we're going to divide a spinner into 4 equal sections labeled 1, 2, 3, and 4. So now we're dealing with a spinner that's in 4 sections. So let's take a look at a spinner that's divided into 4 sections. So this is our 5-section spinner. Let's slide that up. And now we have a 4-section spinner. So this spinner is divided into 4 equal sections. We have our red section, our yellow section, our green section, and our blue section. Now the question is, can we get a probability of 40% out of a spinner that's divided into 4 equal pieces? Well, let's take a look. Well, each of these sections, since it's divided in 4 pieces, each of these sections represents a fourth. So each of these sections represents 1/4. If we use the red and the yellow section, so red, or probability of red, plus the probability of a yellow, so if we added red and yellow, that would be 1/2. And if we did, let's say we did the probability of red, yellow, or green. So probability of red, yellow, or green, that would be, because remember each one is 1/4, so 1/4 plus 1/4 plus 1/4, that would give us 3/4. And of course, if we did the probability of red, yellow, green, and blue, that would be the entire circle, or the entire spinner, which would be 4/4, or 100%. So now if you notice, in this particular spinner, the spinner that's divided into 4 sections, there's not a way for us to get a probability of 40%. We can only get probabilities of 1/4, 1/2, 3/4, or 4/4, which is 1/2. So we're going to have to go with that spinner that's divided into 5 equal sections. So for this problem, our solution is going to be answer choice B. Divide a spinner into 5 equal sections, labeled 1, 2, 3, 4, and 5. Spin the spinner 10 times. Okay? So that's our first problem for today. Let's take a look at our next problem dealing with our goal 3 indicators. So our next problem says, Jose conducted a survey of 30 people to determine how many times a person ate at a restaurant between January and July. The results are shown in the stem and leaf plot below. Okay, so in our stem and leaf plot, we're representing the number of times a person ate at the restaurant. So here, it says, based on the survey results, what is the probability of randomly selecting a person who ate at a restaurant 20 or more times between January and July? Now, one of the things about our stem and leaf plot is that it has a little key. Our key down here looks kind of like this. And so it says when there's a 2 in the stem and there's a 0 in the leaf, that represents 20. So now we want to know, based on our survey, what's the probability of selecting a person who ate at a restaurant 20 or more times? So 20 or more times. That's the key. So let's take a look at our survey. So I can see from our stem and leaf plot that somebody ate there 20 times. Another person, 23. Then we have 24, 26, and 26. Next, we have people who ate in the 30s. We have 34. We have 34 twice. We have 35 3 times. It must be a good restaurant. 3 times. And then we have 37. And we have 38. For the 40s, we have 3 people who ate there 43 times. Woo! 43 times. We have another person who ate there 46 times, and one person who ate there 47 times. Nobody in the 50s, But we do have somebody in the 60s. Somebody's gone to the restaurant 63 times. That's all right. Must be good, some good eating. Okay, so now let's take a look at the number of times a person ate at the restaurant 20 or more times. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we have 17 people who ate at the restaurant more than 20 or more times. So we have to include the 20 because the problem says 20 or more. So we have 17 people. So let's go back to and think about our probability. Remember, probability is the number of favorable outcomes over the total number of outcomes. So our total number of outcomes in this case is 30 because we had a survey of 30 people. The number of favorable outcomes are the number of people who ate at the restaurant 20 or more times. And we said that is 17. Now the question is, can we simplify that fraction? Can we simplify 17 over 30? Right, we can't. You're absolutely right, because the only thing that goes into 30 and 17 is a 1. So we can leave that as 17 over 30. Okay? Now, let's move on to our next question. Our next question involves a simulation. It says, Ms. Thaler's class conducted a simulation using a random number generator to predict how many goals a hockey team will score per game next year. The table below shows how she assigned the digits. So it says number of goals per game and the digits. So if the hockey team scored between 0 and 1 goal, then we assign the digits 0, 1, and 2. If the hockey team scored between 2 and 4 goals, we assign the digit 3, 4, 5, 6, or 7. And if the team scored 5 or more goals, we assign the digits 8 and 9. Now, we can tell by looking at the digits that the hockey team more than likely had a greater probability of scoring between 2 and 4 goals. Now, you might say, Mr. Owens, well, how do you know that? Well, I know that because in order to represent a greater probability, we have to use more numbers. So there were more numbers used between 2 and 4 than there were between 0 and 1 and 5 or more. Okay? Now, let's take a look at the rest of the problem. So it says the class conducted 30 trials. The results of the simulation are shown below. So here we have our set of random numbers. And it says the hockey team will play 90 games next year. Based on this simulation, in how many games will the hockey team score between 0 and 1 goal? Okay, so now what we want to do in this case is we have to go through our random number table, the table of random digits that we have, and identify which digits correspond to scoring between 0 and 1 goal. And I think according to our table, we said it was if we have digits 0, 1, and 2. So we need to identify those. So let's go ahead and do that. So here I see a 0. So we're looking for the digits 0, 1, or 2. So here we have a 0. Let's keep going. There was nothing in this first string. In this string we had a 0. Here we have a 2. Here we have a 0. Let's keep going. We have a 1 here, a 0 here. We have another two 2s, and we have a 1. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 times in our series of 30 trials where the team is going to score between 0 goals and 1 goal. Okay? Now, that's only based on 30 trials. But remember, the question says, if they were to play 90 games, how many times could we expect them to score between 0 goals and 1 goal? So let's take a look. So remember, it says the hockey team will play 90 games next year. So based on this simulation, how many games will they score between 0 and 1 goal? So we know for 30. So for 30 games, remember 30 is our total number of outcomes. We know the probability of favorable outcomes, which is scoring between 0 and 1 goal, that's going to be 8. So 8 out of 30 is equal to, let's call it x over 90. Okay? Now what we're going to do is we're going to solve a proportion. So we're going to solve a proportion. In order to solve a proportion, we're going to cross multiply. So let's do 8 times 90. So 90 times 8 equals 30 times x. So 90 times 8 is 720, which equals 30x. Now we're going to divide both sides by 30. And x is equal to, we have 720 divided by 30 gives us 24. So that means after 90 games, we should expect the team to score about 24 goals. Okay? So remember, the key to this problem is to be able to read the table of random digits and correspond the given information to those random digits. So we were looking for a number for digits 0, 1, and 2. Once we did that, we set up our proportion and we came up with our solution. So we should expect the team to score about 24 goals. Now let's take a look at our last problem in this Goal 3 session. Our last problem says there are 826 deer in an enclosed animal park. Scientists capture, tag, and release 60 deer. A week later, the scientists recapture 100 deer. How many deer should the scientists expect to have tags? Round the answer to the nearest whole number. Okay, so once again, we're dealing with probability. So let's go back and take a look at our problem and identify some key values that we need in order to solve it. The first thing we know is that there are 826 deer in the park. That's important. That would be our total number of outcomes. There are 826 deer. Scientists capture, tag, and release 60 of them. That's important because that would be our number of favorable outcomes. A week later, scientists recapture 100 deer. So they capture 100 deer. How many deer should they expect to have tags? So we said that out of 826 deer, so 826 will be the total number of outcomes, because that's the total number of deer. We expect 60 of them to have tags and be released. 60 of them were tagged and released. Now, it says the scientists capture 100 deer. And the question is, out of those 100 deer, how many of them should have tags? So what we're going to do, once again, we have a proportion set up. So we're going to do this similarly to what we did in the previous problem, and we're going to cross multiply and solve our proportion. So let's go ahead and take a look at that. So if we cross multiply, we would have 826 times x equals, then we have 60 times 100. So 60 times 100 would be 6,000. Okay? Next thing we're going to do to solve for our variable, we're going to divide both sides by 826. Divide by 826, and x equals, let's take a look, 6,000 divided by 826 equals, okay, so we have a lot of things going on here. If we take a look at our calculator, you see we have a lot of digits going on there. So I'm going to write down the first 4 after the decimal point. Now, the question says round the answer to the nearest whole number. That's important. So round the answer to the nearest whole number. So if we take a look at our tens place, in the tens place we have a 2. And we remember our rules for rounding. If it's 5 or higher, we round up. And if it's lower than 5, we stay the same. So in this case, since we have a 2 to the right of our 7, because remember this is our whole number, because there's a 2 here, that means we're going to remain the same. So we're going to stay at 7. So x is going to be equal to 7. So that means we should expect to have 7 deer. 7 deer should have tags, which would be answer choice B. All right, everybody. I hope you enjoyed this session, helping to prepare you for the high school assessment in algebra data analysis. I wish you all the best on the test. Remember, we're striving for 412 and beyond. I'm Mr. Owens, and I'll see you later.